So we are preparing for the test on systems of equations. So this is just a reminder, we have three ways of solving a system of linear equations. We have graphing, we have substitution, and we have elimination or adding down. Okay, so those are the three basic ways: graphing, substitution, or elimination, which is also adding down. Okay, so which method should you use? Okay, so basically graphing, the easiest time to choose graphing, if I say choose it no matter, if I give you two equations and I say solve the system, use any way you want. Graphing is the best option if they're in slope-intercept form, or it's really easy to get them both in slope-intercept form. And obviously, your y-intercept is on a graph. You can't have a y-intercept of 2 3/5 or something like that, okay? So you have to have a doable, manageable y-intercept, and you have to have slope-intercept form. Okay, substitution, sometimes it looks like graphing, but maybe substitution would be better. So is one of the equations as an x equals or a y equals? Okay, don't forget you can use x equals as well. A lot of times bigger numbers work better for substitution, because are you really going to graph something whose y-intercept is -50 or things like that? Okay, so substitution means, can you get one of the equations to be an x equals or a y equals, or is one of the equations already like that? Okay, and finally, elimination or adding down, which is really what we did before, okay, basically is if both equations have like terms, okay, and they line up, the x's are lined up, the y's are lined up, the equal signs are lined up, and then if it's easy to multiply through by something and then add down, could be as easy as not having to multiply through by anything or multiplying through by -1, okay? So these are, if you choose, if I give you the choice and just say solve no matter which way, sometimes I will say solve by graphing. I need you to then graph those, okay? And I need to see the slope-intercept form. Sometimes it will say solve by substitution. I need to see you doing it by substitution, or you're not following the directions. Okay, so here we go. Now, these are, look here, number one is in slope-intercept form, okay? And we will say this is number one here. Okay, so this is slope-intercept form. This is not in slope-intercept form, but it could be, okay? If all I do is add 2x to both sides, okay, I get y equals 2x plus 3, okay? So this is very easy. My y-intercepts are nice numbers. One of them is already in slope-intercept form. And then I would just go down and graph it. So this would be one that would be very doable graphing. So y equals -2x minus 5. So I start here, -5, 1, 2, 3, 4, 5. And this was the y equals -2x minus 5 was the first equation. So then you go -2/1, so down 2, up 2. Okay, and make sure you make your line. The other equation, I'm just going to look up top here, is y equals 2x plus 3. So I would start it up 3, and I would go rise 2, run 1. And ideally, you're going to make sure, don't just leave the dots. You're going to show me with those lines where they cross. And this is the ordered pair, -2, -1. Okay, So that would be a good one to solve for graphing. Okay, do you see I could do that number one at the top by graphing? Just an example. Okay, but again, if I say by graphing, you got to show me the slope-intercept form and then the graph. Another way to do this one could have been substitution. And remember, that's when you put those parentheses around, and instead of a y, you put what y equals. So this bottom equation is negative 2x plus negative 2x minus 5 equals 3. So I'm substituting into the other equation. So that becomes a negative 4x minus 5 equals 3. Then I'm going to add 5. Negative 4x equals 8. And then I'm going to divide by negative 4. So x equals negative 2, which it did on the graph as well. And then I choose either equation. I would probably choose the top one, because I always choose the top one, but it's also easier. Y equals negative 2 times x minus 5. So that is negative 4, actually a positive 4, plus a negative 5. So y equals negative 1. So my ordered pair is negative 2, negative 1, and it's the same as it is down there. So kind of just saying, which way would you want to solve? Okay. Now, number 2 right here, I'll say this is number 2. Again, you could use substitution by substituting this in for my y and do the same thing we just did. Or you could also use graphing. This bottom one is good to go. But for this one, I would start by minusing the 2x. Okay. And then I would get, I'm going to make this down here, 3y equals negative 2x plus 21. Okay. Then we're going to divide everything by 3. 3y, not 3y, the y's cancel. What am I doing? Y equals a negative 2/3 x plus 7. And this is another nice one because the y-intercept is on the graph. Okay, the y, so this could be done by substitution or graphing. I'm just kind of going to tell you either way, that works as well. Okay, same thing for the bottom one down here. You could either get, it's easy to get them both in slope-intercept form. So this top one, I would minus 8x. So my slope-intercept form is y equals negative 8x plus a negative 16. Now, the only problem with this, do we want to plot negative 16 to start? So I would say this is not actually a graphing one. This would be probably a substitution one. Now, remember, when we minused that 8x, okay, we got y equals negative 8x plus a negative 16. I put that in parentheses, and I put it in for y. So then I would substitute anywhere I saw a y, negative 8x plus a negative 16. And that still equals this, which is negative 5. And then I combine my like terms. I don't have anything to distribute. So that's a negative 11x plus a negative 16 equals negative 5. Adding 16 gives me negative 11x equals 11. So dividing by negative 11 gives me negative 1. And then again, plug it into either the top or the bottom equation. I always choose the top if you know me. Y equals 8 times, or not y equals, y plus, I'm using this equation, y plus 8x, which is negative 1, equals negative 16. So y plus a negative 8 equals negative 16. So when I add 8, I get -8 for y. So my answer would actually be -1, -8. But again, graphing and substitution are two very similar types. Okay. Next, there we go. So an elimination is what we just kind of went through. So elimination means if things are lined up and down, and sometimes maybe you want to multiply through by one number, not always both, but it kind of depends on what you're given. Okay? Okay, so on the test, there's going to be ones where I'm telling you, do this by graphing, or do this by substitution, or solve this by elimination. Then there'll be somewhere you get to choose. You solve it and you choose your best way that you like doing it. So just be careful. On the review worksheet, make sure you're looking today's review worksheet at some of those questions. Remember, if you ever get something like 6 equals 6, that is infinite number of solutions. Remember, if you get something where things cancel out, or you get something where 0 equals 0, that's, again, infinite solutions. If you get something where 0 equals 6, that's no solution. Remember those, okay? So something where all of the variables cancel out and you're left with 0 equals 0 means infinite solutions, or 0 equals 6 means no solution. So make sure you're doing the worksheet for today, and please make sure you do today's formative. Let me know if you have questions before the test, okay? Okay, have a great day.